In the absence of outliers, the sample mean, or average, is our best measure of the central tendency of a single variable, our best guess of the typical value of a variable in a sample. To characterize the dispersion or spread of our data around the mean, that is, around the center, it would seem natural to define the deviation of each x from its mean, and choose the average of the deviations as our measure of typical dispersion. Consider this sample of 5 observations on the variable x. Stop the video and confirm that the mean of x is 4. Calculate the deviation of each observation from the mean, and find the sum of those deviations. Finished? It's not hard to show that this result generalizes, that the sum of the deviations from the mean is always 0. Positive deviations are offset by negative deviations, so the average is always 0. One clever solution would be to take the average of the absolute values of the deviations, but the resulting function doesn't lend itself to advanced analysis. For example, it is not differentiable. Another solution is to square each deviation and then take the square root. The actual measures statisticians typically use with a data sample are the estimated variance and estimated standard deviation, where we divide by n-1 instead of n. The case for doing so deserves its own video. I'd summarize the argument by saying that using the root mean square error, that is, dividing by n, would yield a biased estimate of the parameter characterizing the process that generated our data. And, of course, in very large samples, the two statistics yield virtually identical estimates.